VAN, A to neutral, positive 1/3, VBC. And from line B to neutral, same, 1/3, VBC. And lastly, from C to neutral, that's going to be negative, and it's going to be 2/3. The next line is now slightly different. We have two negatives. So one is here, phase A, switch S4 is on. B is also connected to the negative polarity of VBC. So S6 is on here, and VBC is connected to the positive. So S5 is on here. Let's rearrange this again. And this time we have two connected to the negative and only one connected to the positive. But we still have these two impedances down here are in parallel. So the impedance, equivalent impedance is going to be half. And then the one on the top is going to be the full impedance. So you're still going to get this 2/3 and 1/3 of VBC over those voltages. Let's first fill in the phases. So phase A is connected to the bottom, so we can put that here.
So
Phase B also
here,
connected to the bottom, nibble down here, and C is the one that's connected to the positive.
and the C is here.
Alright, so using this diagram, let's go to the tables and fill them in, starting with the line-to-line voltages. So VAB, here to here, they're connected, that is
A
0.
here,
VBC, from here to here, that's going to be the negative VBC. And then from C to A, we're going to get the full positive
C A,
VBC.
so VDC.
Now the line to neutral. So VAN is here, and we're
A,
getting a negative
so it is negative.
1/3 VDC. Then the V from B to the neutral,
B
that's also going to be
to
negative
neutral,
1/3
so
VDC.
minus 1/3.
And then from C to neutral, that's going to be
C
positive
to neutral,
2/3
2/3.
VDC. So this one, the A is positive, so switch S1
A
on
is
here.
positive,
And the other two, so phase B is negative,
B
so
and the C
S6
negative.
is on, and C is negative, so
C is
that's
negative.
2 is on.
Okay,
Okay, again, let's rearrange it. This is
So
going to be the
A,
same topology
B,
as
C.
just the last one. And so let's fill in our phases. A is the one at the top,
So
B and C are
two-thirds,
going to be
A.
negative.
B is negative,
And we do
1/3.
the same voltage,
C is
but
negative,
let's just go through each
1/3.
of the phases. So the line to line AB
AB,
is going to be full VDC.
AB, VDC.
And BC here,
BC, the same.
0 to short it. And
0.
CA, here it's going to be the
CA,
negative.
CA minus VDC.
Now line to neutral, so now A to neutral
A to
is
neutral.
2/3
So we have
VDC.
A to
And
neutral, 2/3.
The BN
B
to here,
to neutral,
1/3
minus 1/3.
VDC. And you can see it's going to
C
be
to
the same
neutral, minus
from
1/3.
C to N, so it's going to be negative 1/3 VDC. Next one. Now we're looking at phase A being negative, so switch S4 is on. And
A negative,
B is positive, so
B is
S3 is on.
positive,
And VC negative, so S2
C
is
negative.
on. If we rearrange this configuration again, we get the same topology we were just looking at. Just fill in the phases. A is
A,
negative, B is the
so
positive
A
one,
is negative,
C is the negative connection.
B is
So, okay,
positive,
go back to
C is
voltages
negative.
again.
Okay,
The A to B,
A to B,
negative, VBC. And
A to B,
VBC,
negative,
here to here, the
B to
positive
C,
VBC.
positive,
And C to A is
C to A, the same,
going to be 0.
0.
So VAN, neutral, that's going to be negative 1/3 VDC. Then we have VBN, so from here to the neutral, positive 2/3 VDC. And C to neutral, Cn. That's going to be a negative 1/3 VDC. Last, switch state. This is actually going to be easy. Negative, so S4 is on.
Negative.
The VD is negative, so it's connected to the negative, so switch 6.
Active.
6
Here.
is on. VC is negative, so switch S2 is on. This one, everything's connected to the negative, so it's going to be a lot easier. Here's our
A short
diagram.
circuit.
We can just fill in A,
So
B,
zero
C,
voltage.
as they're all going to be the same. And we can very easily fill in these because everything's going to be 0. So we get
all
from
of
0,
them are
0, 0,
because they
for the
tie
line
together.
voltages, and all the line to neutrals.
They don't
There's no
connect to
voltage
battery.
going over any of them, so again, they're all going to be 0. So we filled in all the charts, and we're going to notice
So how many
some
states?
things about
1,
them.
2, 3, 4,
So here's
5,
a
6,
summary
7,
chart
8.
of all the
Total
different
8 states.
cases.
If you
So
can
we're
create
going to
another one, you
switch
can
states,
publish
8 different
one
switch
IC
states.
table.
2 of them,
If you can
so
find a 9.
all positive or all negative, give you 0 across everything. But there are 6 states in between
So we call
that
this
can
is
produce
active.
different
6
voltages over
active state.
the load
2
voltage.
0 voltage.
And for the line-to-line voltages, you can see that we can only get 3 different values. We're either going to get a positive VDC, a 0, or a negative VDC.
So
And
this
we
is
can
3
get all the different
different
combinations
situations.
of those 4
Positive, negative,
instances. So
0.
we can use those in our switching
So line to
sequence
line.
we'll do later.
Positive,
And
negative,
for the
0.
line to neutral, we
The
get a
neutral,
little bit of a different combination.
we have
Here you can see
2/3,
either
1/3,
get
1/3.
a positive 2/3. I'll circle one example of each one. A positive 2/3 VDC,
So positive,
a positive 1/3 VDC,
positive
negative
1/3,
1/3 VDC. That's right, they're all the same.
2/3, negative 1/3.
Negative 1/3 VDC, or a negative 2/3 VDC. So you have 4 different values that
4
we can have.
different
See
values.
over the line to
Line
neutral.
to neutral.
Well, there's only 3 voltages that we would see over the line to line.
That is line to line only
We're going
3.
to focus a little bit more on the line to line. I think it's actually more intuitive to look at the line to line, but it's good to know about the line to neutral if you happen to have that type of load, or you want to really understand each individual voltage over the load. These tables summarize all of the line to line voltages that you can have and the line to neutral voltages. And then the next step is to switch in a sequence between these different
So
states
sequence.
such that you
How
get
can you
the
choose the
waveform, the
sequence?
AC waveform at the output that you want. So that will be the focus of another video.
Okay, so in this video, we learn the DC to 3-phase AC inverter. So I will explain again because you may not catch the main idea. So I will use the blackboard to explain again in a slow speed. So if you have question, you can interrupt and let's mention. Okay, now I will explain what is DC to 3-phase AC inverter. We call it is DC to 3-phase AC converter. So you change from DC to 3-phase AC. And we have another name, we just call it is inverter. So sometimes industry people, they always say do you want to buy an inverter? They don't say, do you want to buy a DC to three-phase AC converter? But they have the same meaning, totally the same. So if you want to learn the inverter, then you have to go deep. So what is inverter? DC. So VDC. So what is VDC? We can think the VDC is battery, right? We use battery, like electrical vehicle. We use maybe 500, 600 batteries then to drive the motor. But this is too complicated. So in our mind, we can think the DC has a neutral point. So we call this is neutral point, 0 volt or ground. So if you have 600 volt, then you can separate 300 volt to 300 volt because 300 volt series another 300 volt become 600 volt. So the same meaning. So we call this is ground, or we call this is 0 voltage. But do you think the 0 voltage is DC ground or AC ground? DC. It is battery. So we call this is DC neutral. DC neutral point. But what is your DC neutral point? It is only in our mind, not real, because easy to explain. Otherwise, your brain will be stuck. So you have to think the DC separate to two parts. Half of them are positive, half of them are negative. Then you can create AC. If all of them are positive, how can you create AC? So we have to use our own brain to think half positive, half negative. Then how many switches do you have? We have 6 switches. So we have 6 switches. So can you give them name? Yes, we have A switch, T1, T1 plug. We have B phase switch, T2, T2 plug. We have C phase, T3, T3 plug. So we have A phase, B phase, C phase. We have 3 layers. So then we have load. Load. What is your load? Motor. So what is motor? Inductance, right? Inductance. So we can think the motor is inductance. So inductance. But inductance also includes resistance, because if you have winding, it will create resistance, also inductance. So what is inverter? DC to AC. So this is DC. This is 3-phase AC. So what is this phase? A phase. How about this one? B phase. How about this one? C phase. So we can say, oh, this is A phase. This is B phase. This is C phase. How about this point? Neutral, right? So we call this N is neutral. So do you think the neutral is AC neutral or DC neutral? AC. Because this is a motor. So it is AC neutral. So do we think AC neutral is equal to DC neutral? This is DC neutral. This is AC neutral. Can we use a line to connect 2 points? Is these 2 points have the same voltage? Yes or no? Do you think AC neutral and DC neutral you can use a line to connect, or you should isolate? Isolate. Because one is DC, one is AC. They are different. So you can say this point is equal to this point because in fact they are isolation. They are not tied together. So they don't have the same voltage. So they are different. One is AC, one is DC. Then I have a next question. Do you think that the three phase is dependent or independent? A rely on B, B rely on C, then we call it is dependent. If they are operated by themselves, it is independent. So do you think that they are independent or dependent? Independent. Because when you operate A, do you consider B? You only consider T1 on, T1 prime off, T1 prime on, T1 off. You don't care B and C. So when you operate B, you only consider if this one on, this should be off, this on, this should be off. So we call they are independent. Control or independent switch. They don't care another phase. They operate by itself. So then next question is, how can you operate? Because you have 8 switch. Now, what is the principle of AC motor? You can say AC motor has A phase. AC motor has B phase. AC motor has C phase. Right? A phase, B phase, C phase. And what is the phase shift or phase delay? How many degree? 120. So you know, this is 120. Should be A first, B next, C next. So this is 120, 120. So the phase shift should be 120. And A, then B, then C. So if you want to get A phase voltage, do you think T1 should be turned on or turned off? If you need A phase voltage, should you choose this one or this one? T1, because you need positive A phase. So then A phase, this should be 1. How about B phase? If all of them are 1, then become 0 voltage. So if this is 1, B and C should be 0. So 1, 0, 0. Then I can get A phase voltage. If I need B phase voltage, then this one should be 1. So T2 should be 1, but T1 and T3 should be 0. If I want to get C phase, it should be 0, 0, 1. Then first I get A phase, then I get B phase, then I get C phase. So we have to follow the sequence. If we go A and C and B, and then C and A, do you think that the motor will rotate? No. So you have to follow the phase shift. We call phase sequence. This is A, B, C, and the phase shift angle 120 degrees. We have 2 rules. One is phase sequence, another is phase shift. You cannot randomly control. If you randomly control, then the motor just stuck and it doesn't move. So you have to follow the fundamental rule. Otherwise, you cannot make the motor run smoothly. So then, if you go this way, then it is okay. The motor will rotate. So if you see this is 1, 0, 0, this is 0, 1, 0, how about this one? If you have a vector, this is 1, 0, 0, this is 0, 1, 0, how about this one? Which state should you put? Which one? Yeah, A plus B. So you have A vector, B vector, you have A vector, you have B vector, you need this vector. How can you create this vector? This vector equal to A plus B, right? If you have this vector and then this vector, I want to create this vector, this is A, this is B, how about this vector, A plus B? So we call this vector addition, right? This is fundamental math, vector addition. So if you want to create this one and then this one, then what is this one? This should be A plus B, so it is 1, 1, 0. So 1, 0, 0, 0, 1, 0. We have 1, 1, 0. So this is 1, 1, 0. How about this one? If I have B, I have C, but I need this vector. How can I create this vector? B plus C. So I use this one. 0, 1, 1. So 0, 1, 1. So I can create another vector, no problem. So if I have C, I have A, I want to create this vector. Then this is 0, 0, 1, 1, 0, 0. This is 1, 0, 1. So how many vectors do I have? 6, right? 6. So I can go from here, 1, 0, 0 to 1, 1, 0. Then 1, 1, 0 to 1, 0, 1. And then 0, 1, 1. And then 0, 0, 1. And then 1, 0, 1. How about next one? 1, 0, 0. But repeat again. So we can put here, before this is 1, 0, 1. So then we can rotate in this direction. So we can call this is clockwise, like a clock. Rotate this one. If you want to go this way, we call counterclockwise. Then what should you do? You have to 1, 1, 0, 0, 1, 1, 1, 0, 1. You have to go another way. So then you can go this way, you also can go this way, if you follow this rule. So now you have a basic idea. I have to follow this rule. Otherwise, my motor couldn't rotate, right? So how about 1, 1, 1? If I have 1, 1, 1, then what happened? So if we have 1, 1, 1, we have this one close, this one close, this one close. Then we have motor, close, close. We have motor, and we have neutral, and then we have this circuit. So what is the voltage across the winding? 0. Because you have no loop. And then you put every winding tied together. So what is the voltage? 0. So we call this is 0 voltage. call this state is 0 voltage. So what is the usage of 0 voltage? You have a motor, but you put 0 voltage, then what happens? No work, right? Because you cannot add any energy, so it is only 0 voltage. So if you drive a car, then you falling down, then you can put the clutch into empty. Then what happens? The car still running, but out of control. You have no gasoline, you have no brake. It is free running. So we call this is free running. So it is like a car. Then you just put your clutch into empty, but you still have current. The current still continue flow. So if you put a car in the empty, the car still have some speed, but cannot control because you have no gasoline. If you have no brake, it is just free running. In another way, how about this is 1, 1, 1? How about 0, 0, 0? So now we can put 0, 0, 0. Here is disconnected. So how about the voltage? Also 0 voltage. Also free running. Or we call it is free running. So we can say this one 0 voltage, 1, 1, 1, or 0, 0, 0. Only in this port. No voltage, no voltage. So how many states do you have? This switch has 2 states. This switch 1 or 0, 2 states. This leg 1 or 0. So we have 3 legs. Each leg 2 states. Totally we have 8. Right? 8 states. Switching state. But we have 1, 1, 1 and 0, 0, 0. We call it is free running. Or we call it is 0 voltage state. So the useful state only 6. We call it is active state. Useful state only 6 state active. So we have here. So you can put the sequence in this way, or you can put in this way. So the motor will rotate in clockwise or counterclockwise. So now we have basic idea. We have to follow this. If you do not follow this, then what happens? The motor doesn't work. You have no way. You have no way. So how about each step? How many degrees? From here to here, 120. How about this one? 60, 60, 60, 60, 60, 60, 60 degrees. So if you have a motor, each step 60 degrees, 60 degrees, 60 degrees, each step. But now you say, I need a vector here. How can I create a vector here? Because I need a circle. If this is a circle, I should reach any angle. Then I can create a circle. But now you say you only have 6 steps, which means each step is quite large, like this. But what happened? I want to this. But each step is like this. Then do you think this is good enough? No, it is not good enough. So totally how many steps do you have? Only 6 steps. So we call this 6 step. Voltage, source, inverter. 6-step voltage source inverter. Is this good? No. The resolution is too bad. The resolution is very bad. So if you have a lens, if you have a ruler, the ruler just show you, oh, this is 10 centimeter, 10 centimeter, 10 centimeter. Now you try to measure a lens. The lens is like this. Then can you tell me how many centimeter? We don't know, because this is your resolution. You only show 10 centimeter. If I have a lens here, I can call it is 10 centimeter. But if I have a lens here, then how many centimeter? I don't know. So we call this is low resolution. So is this good? No, it is not good. But it can work. So if you put 6-step voltage source into the inverter can rotate, but the performance is not good because each step is 60 degrees. Too much. So I need to make the resolution better. So I hope each step should move like this way. Then what have you do? You have to improve your resolution. So we will discuss this later. So now we have basic idea. We have 6-step motor. If we have 6-step motor, the motor can rotate. But if the motor rotates, it is create square wave. So it is create square wave. The line voltage is like this. If it is the phase voltage, it is like this. So this is 2/3, 1/3, 0. Then minus 1/3, minus 2/3. It is like this, right? If it is line, then you have VDC minus VDC and 0. So do you think that this is good? No. You say, what I need is sinusoidal. I need this voltage. I don't like this. But you only can get this. Why? Because you have switch. Switch only 1 or 0. Can you get a switch 0.5? No, 1 or 0. How many switch do you have? 6, right? 6 step. So you only create this waveform. We call this is square wave, not sine wave. But what I need is sine wave. So this inverter is not good because it only creates square wave. So the fundamental is like this. But it is not sinusoidal. Then if you put this inverter into a motor and you put this inverter to run elevator, then what happens? So now you put this inverter to run elevator. So the elevator moves from here, but you want to reach here, right? Then the elevator moves slowly, and when it reaches 100 RPM, it stops. Then it's shaking. Why? Because you do not get sinusoidal waveform. You only provide square waveform. So the harmonics is huge. So if you put this kind of inverter into motor, the speed you can adjust is from 100 RPM to 1,800 RPM. Below 100 RPM, doesn't work. It only shaking. So can I put this inverter into elevator? No. Can I put this inverter into MRT vehicle? No, because the door is here But when I reach here, I shake it. So I have no chance to approach the door. Then the door cannot open. If I put this into elevator, then I want to go to third floor. Then this is the floor, third floor. But the elevator stop here, Then open the door, then people jump and pull it down. Then create dangerous. So this happened before, because this one cannot reach the floor. So we call this kind of inverter is low performance inverter. So we call this is low performance inverter. It is very bad, but it is useful if you use to work for pump water. It is okay, because 1 RPM is good enough. If you use this to air conditioner, it is okay. Or push a fan, it is okay. Because fan, you don't need to put 1 RPM. You can work at 100 RPM. It is okay. So if you work for fan, if you work for pump, it is good enough. So we use for pump or for fan. So this is the fundamental idea. And then you ask a question, if this is so bad, why do you teach me? The reason is because it is basic, fundamental. If you don't know 6 steps, then you don't know PWM, right? Because you have to learn 6-step inverter. Then you can understand why do we need PWM. Okay. So now I will explain the fundamental idea for you. So we have this structure. Then we have to follow the step. So what is the step? 6 steps. So we have to draw the 6 steps. So I will keep here and I will draw this one. This is 1, 0, 0. This is A. This is B. 0, 1, 0. This is C. 0, 0, 1. And then this is 1, 1, 0. And then this is 0, 1, 0. How about this one? This is 0, 1, 1. And how about this one? This is 1, 0, 1. So we have A, B, C. So then we want to draw this one. So we start from here. So we have first step, 1, 0, 1. How about the next step? 1, 0, 0. How about the So what is 1, 0, 1? Means AC in the up. So A, C, and B at the bottom. B here. So we have this one, this one. So we can draw this way. How about next one? A is the top. So A is top. B and C at bottom. B and C. And we have this one and then this one. And the next one, 1, 1, 0 is AB and at the top. So we have AB at the top and the C at the bottom. Okay. So 0, 1, 0 is B at the top. AC at the bottom. Okay. 0, 1, 1 is BC at the top. BC at the top. A at the bottom. And then 0, 1, 0 B at the no 0, 1, 1. And then 1, 0, 0, 1. C at the top, AB at the bottom. So we have this one. And the 101, AC at the top. And the B at the bottom. And the 100, A at the top. And the BC at the bottom. So we draw each state. So we have the state like this. Then we want to draw the next one. And then next one, VB0. And the next one, VC0. VC0. And then next one, we want to draw VAN. Then VBN. Then VCN. So first, we want to draw the phase voltage. So how can we draw this waveform? So first, we have VA0. So this is 0. This is A. And this is 101. So we have to draw 101. 101. So how about VA on? A is here. So we turn on here. So you can see the circle we have A here. We turn on A here. This is A. Then we have B and C go back. This is N, B and C go back. And go here. 0.5 VTC, 0.5 VTC. 0 is here. So what is the A phase voltage? 0.5 VTC, right? So you can say VA0 is 0.5. VTC. Here, A is up 0.5 VTC. Here, A is up 0.5 VTC. Here, A go to down, so A is equal to negative minus 5, 0.5 VTC. A is at the bottom, minus 0.5. B at bottom, B at bottom, B at bottom. So we can draw VDO, right? How about VCO? C at top, so VCO 0.5 VTC. C at bottom, C at bottom, C at bottom, C at top, C at top, C at top, C at bottom. So we can draw this is minus 0.5 VTC, minus 0.5 VTC, minus 0.5 VTC, 0.5 VTC, 0.5 VTC, 0.5 VTC, minus 0.5 VTC. So now we want to check phase sequence. VA all jump to negative here, right? VB all jump to negative here. VC all jump to negative here. So what is the phase sequence? A, B, C, right? So we have VA, VB, VC. Is it correct? Yes. A, B, C, right? How about phase shift? Here to here, how many step delay? 1 step, 2 step. Each step 60 degree, 60 degree. So B delay A how many degree? 120. So you have A, you have B, you have C. So 120, 120, 120. So do you think that the phase sequence is correct? Yes. Do you think that the phase shift is correct? Yes. Do you think that the motor will rotate? Yes. So you can check phase sequence and the phase shift. So no problem. So now we want to draw VAN. What is VAN? This is N here. So if you want to draw it is like this. So A, C, B. This is N, right? So this is 0.5. 0.5. How about this total? 0.5 plus 0.5 become 1. So this is VTC. And this is Z, Z, Z. If you have resistance parallel together, then how about the result? 0.5 Z, right? This is Z. So total is 1.5 Z. But this occupy 0.5 Z. So it occupy 1/3 VTC. How about this one? Occupy 2/3 VTC. So you can show VAN is 1/3. So VAN is positive 1/3. VAN is 1/3, and VCN is 1/3. 1/3. And VBN is here to here. VNB is 2/3. How about VBN? VNB is 2/3. Minus. So you can say it's minus 2/3. So you can draw this is minus 2/3. So you can draw VN, VBN, VCN quickly, right? How about this one? VN is 2/3, VB and VC minus 1/3. So you can draw this is like this. Okay, this is A is here, so 1/3. Here A is negative, minus 1/3. This is plus 1/3, plus 2/3. So you can draw easily. How about this one? A is here, minus 2/3. A is here, minus 1/3. A is up, so plus 1/3. A is here, plus 2/3. So you can draw A phase easily like this. So how about B phase? So minus 2 here, minus 1. B minus 1/3. And then minus 2/3. And then minus 1/3. So you can easily draw VBN. How about VCN? This one, 1/3. This one, minus 1/3. And this one, minus 2/3. And this one, minus 1/3. And this one, 1/3. Plus 1/3. And this one, plus 2/3. And plus 1/3. Then minus 1/3. So you can easily draw by your own. If you know the idea, then you just follow the same rule. So you can draw VA0, VB0, VC0. You can draw VAN, VBN, and VCN. So I think we have 10 minutes break, and we will come back next class.